Okay, I'm going to go ahead and get started. And everybody can hear me at home?
Yes, ma'am.
Okay. All right. We're going to hit 6-1 tonight. Um, y'all at home can't see that, but we have one person in class, so I am just going to be going through the problem. So if you want me to stop, somebody's going to have to say something. If you have any questions, you're going to have to speak up, or I'm just going to basically be talking through the whole thing tonight. So the first thing on a composite function, whoop, I need a pen. It's when we're going to insert one function inside of another function. So if I have, let's say I have f of x is equal to 2x and g of x is equal to x minus 5. Well, what I'm going to be doing.
Is it okay if I join online?
Is I'm going to be setting this inside of this function. Inserting. Now, you work from the inside out. G of x first, then f of x. So when I'm looking at a table and I need to find f of g of 1, to start with, I need to know what's g of 1. So up here at the top, I've got x is equal to 1. So g of 1 would be 0. So now I want f of g of 1. So where is x 0 at? Right here. F is 5. So f of g of 1 is going to equal to 5. Does that make sense? All right, let's try. How about g of f of 2? G of f of 2. So I need to know what is f of 2. X is 2. F of 2 is equal to 1. So that means if f of 2 equals 1, now I want g of 1. So when x is 1, g is 0. So g of f of 2 is equal to 0. Okay? Again, guys, you're going to have to say something if it's not making sense or you have a question on it.
That didn't make sense. Can you do another one, please?
I'm sorry, sir. Say it again.
Can you do another one, please? I'm confused.
Okay. What if I have f of g of 2? I got to work from the inside out. So the first thing I want to find out is what is g of 2. So remember the generic is f of g of x. when x is 2, g of 2, just following straight down on this table, g of 2 gives me a negative 3. So if I have g of 2 equals to negative 3, f of g of 2, I now need f of negative 3. This is negative 3. So I need f of negative 3. So I go back to where is x negative 3? F of negative 3 is equal to 11. Inside out.
Thank you.
I need f of 3, g of f of 3. F of 3 is a negative 1. So whatever I get here, now I need to do that in g. G of negative 1 is 0. A little bit better, just follow, start from the inside and follow your way out.
Thank you.
Okay? Thank you for asking. All right, so let's go to when it's not on a table and it's just in two functions. So what if I have f of g of 4? My f of x, and I am looking at problem 13. F of x is equal to 2x. And g of x is equal to 3x squared plus 1. I want to know what is f of g of 4. So again, inside out. I need to know g of 4. Whatever I get for g of 4, that's going to give me my f of x. So 3 times 4 squared plus 1. 3 times 4 squared is going to give me 3 times 16, 48, plus 1 is 49. So g of 4 is 49. So if I need f of g of 4 now, that means that I need f of 49. So 2 times 49 gives me 98. So f of g of 4 is going to give me a 98. Yes? It's the same as the table. You find out the value of your inside function and plug it in to your outside function. About 14. F of x, 3x plus 2. G of x, 2x squared minus 1. And we'll do How about g of f of 2? So first thing I need to know is what's f of 2? 3 times 2 plus 2. So f of 2 is going to equal 6 plus 2. F of 2 is equal to 8. That means that I need g of 8, because f of 2 is 8. So I need g of 8. So that's going to be 2 times 8 squared minus 1. 2 times 64 minus 1, 128. Minus 1 gives me g of 8 at 127. Yes? How are we feeling on these? Are we good, or should we do something a little more complicated? All right. It does get a little bit more of a challenge when I do not have a value and I just have to leave the variables as they are. Now, we need two things on here. I need to know what is f of g, and I need to know the domain. So I'm going to kind of answer that domain first, because if I'm doing problem 23, I have f of x is equal to 2x plus 3. That's linear, right? That's a straight line. So my domain is all real. G of x is equal to 4x. That's also linear. So domain is all real. So my domain for f of g of x is going to be all real. If both of these are all real, then the composite function of them both is also going to be all real. But what about what is f of g of x going to look like? I have got to put g of x inside of f of x. Every place there's an x, I need to replace it with my g of x. So I have 2 times 4x plus 3. Simplifying gives me 8x plus 3. Okay? Let's go a little bit more complicated. How about g of f of x for 25? I have f of x is equal to 3x minus 1, and g of x is equal to x squared. I want g of f. So I'm going to put f of x into wherever I have an x in my g of x. So g of f is going to be three x minus 1 squared. Now, you know that's just going to come out to a quadratic, right? What's the domain of anything quadratic? This is linear, this is quadratic, all real, all real. So my domain here is also going to be all real. And we can FOIL this out, 3x minus 1 times 3x minus 1, so we get 9x squared minus 3x minus 3x plus 1, 9x squared, what, not minus, 9x squared minus 6x plus 1. Okay? How are we feeling about problems 23 through 26 here? The main thing is just to remember to work from the inside out. All right. The question on the domain, though, does get a little bit more complicated. And we've looked at these rules before. You should have them in your notes. What is the domain for f of x is equal to 1 over x? Remember, x cannot equal 0, right? Somebody hit a mute button, please. If f of x is equal to the square root of x, x has to be greater than or equal to 0. And if f of x is equal to 1 over the square root of x, x must be greater than 0, right? So when we get into our next composite functions, we need these rules about the domain. So I still need to know what my domain of my composite function is. So for 29, I'm going to do f of g. F of x is 3 over x minus 1, and g of x is 2 over x. So I have this guy in play right here. I can't have a 0 in my denominator. So to start with, your domain is x is not going to equal your inside function. If I'm doing f of g, then I'm going to take the restriction from my inside function. X cannot equal 0. And that's part of my answer. X cannot equal 0. Normally, I would do x minus 1 cannot equal 0, right? But the thing is, it's not going to stop there. If I do x minus 1 equal to 0, that would be a 1, right? So this x right here cannot equal a 1. That means that this 2 over x cannot equal a 1. Remember, you're going to put 3. Well, if this 2 over x is equal to 1, then 1 minus 1 would be a 0, and I would end up with a 0 in my denominator. So what I got to do is find out what would give me a 1. So I'm going to do 2 over x equals 1, and I'm going to solve. Well, if multiplying both, I get that x is equal to 2. So my domain goes back to the first one, the very first inside function. I started there, x equals 0, and then 2. So there's my answer. Domain is x cannot equal 0, and x cannot equal 2. Now these are some confusing ones. When we're talking about domain. So let's try the same one, 29, but this time we're going to do g of f. Again, f of x is equal to 3 over x minus 1, and g of x is 2 over x. What is the domain of g of f? Start with your inside function. F of x, x minus 1 equals 0, so x equals 1. That gives me the domain for g of f is going to start with x cannot equal 1. Any restriction for the inside function automatically goes in. Okay? All right, now remember, you're doing g of f, right? So you're going to have 2 over 3 x minus 1. How do you divide a fraction by a fraction? I mean, if I were to set this whole thing equal to, let's just do it this way. This outside function, because I'm on the outside since I'm doing g of x, I have to have x does not equal 0, right? So I've got to take this here and set it equal to 0 because this cannot have a 0 in the denominator. So 3 over x minus 1 equals 0. How would I start solving that? A rational equation, you always start with multiplying by that denominator. Well, these two cancel, but this is a 0, and I get 3 is equal to 0. And that's a no solution, right? So that means there is no number that would give me a 0. And that means I'm done. How are we doing on these? Okay, domain of a composite function is what we're working on. How about 32? We'll do f of g. F of x is equal to x over x plus 3. G of x is equal to 2 over x. I have restrictions for f of x. X plus 3 equals 0. X cannot equal a negative 3. I have restrictions for g of x. X cannot equal a 0, right? Since the g is the inside function for my domain of f of g, I'm going to start with x cannot equal 0. Go ahead, whatever restriction you have for your inside function, that's going to be part of your answer. All right, now I'm going to take that inside function and I'm going to set it equal to the restriction of the outside. So I'm going to say 2 over x equal to a negative 3. I can't have a negative 3 right here. I'll end up with that 0. So since I have to put 2 over x in there, then that cannot equal to a negative 3. So multiplying both sides by x, I've got 2 is equal to a negative 3x. Dividing by that negative 3. X is equal to a negative 2/3. So x cannot equal a negative 2/3. How are we doing? These making sense, guys? Do I need to work some more before?
Can you do another one?
Mm-hmm. So on 31, we're looking for the domain of f of g of x. F of x is equal to x over x minus 1. So just for f of x, what's the domain going to be? Cannot equal a 1, right? G of x. X cannot equal a 0. So if I'm doing f of g, my inside function is g, that's automatically part of my answer. Does not equal a 0. I cannot have a 1 here. X cannot be 1 because I'll end up with a 0 in my denominator. Now, since I'm doing the composite function, I have to put g into f. I need to be inserting right there. So that means that this negative 4 over x cannot equal a 1. So I got to find out what number would give me that 1. And if I multiply both sides by x, I get that x is equal to negative 4. So that's going to be the second part of my answer. Why don't you guys try to get me, we'll use 31 again, and let's see what we get for the domain of g of f of x. Okay. So if I'm going to do, oh, excuse me. Oh, for crying out loud. G of f. Then I still have x over x minus 1 for f, and I still have that x cannot equal a 1. And I still have x cannot equal to a 0. But this time, for my answer, I got to put in the x automatically, the f, because that's my inside function. So x cannot equal 1. All right, now, again, to do the composite, this function has to be put inside. So this whole function cannot equal to a 0. I need 4 over x minus 1, right? Well, this x over x minus 1 cannot, whoops, I'm doing it backwards, cannot equal to a 0 because I can't have a 0 down there. So I'm going to have x over x minus 1 equals 0. Multiply both sides by that x minus 1. And I get left with x is equal to 0. So x cannot equal 0 is my final answer. Negative 1 and 0. What you think? A little better? Okay. The last section, and this is just about, is I'm gonna move for me. G of f and f of x, f of g equal functions. Are the composite functions equal? So all I'm going to do is this here. Right there that it says in the directions. I'm going to say, does f of g of x equal g of f of x? My answer is going to be yes if they both simplify down to x. So if I have f of g of x, and I'm looking at problem 39, then I have g of x going into f of x, and g of x is equal to 1/2 x. Now f of g means that g has to go into f. So I have f of x 2 times 1/2 x, and that simplifies to x. So far, so good. Now, if my g of f also simplifies down to x, then yes, they are going to be equal to each other. So it's going to be 1/2 times 2x. And yep, that equals 2x. So when I find out if they are equal to each other, if they both simplify down to x, and they do, so my answer is a yes. Let's try problem 42. what am I trying to find out? For 42, does f of g of x equal to g of f of x? Well, if f of g of x equals x and g of f of x equal x, then they have to be equal to each other. So my f of x is x plus 5. My g of x is equal to x minus 5. So for f of g, I have to take g and insert it into f. So I will have f of g is equal to x minus 5 plus 5. Yep, that equals x. G of f of x, that means I need to take f of x and put it into g of x. So I have x plus 5 minus 5 equals x. So my answer is yes, they are equal to each other. How about 44? F of g of x. F of x is equal to 4 minus 3x, and g of x is equal to 1/3 times 4 minus x. So f of g of x means I need to take and put g of x into f of x. So I have 4 minus 3, that part right there, but instead of x, I have 1/3 times 4 minus x, right? So that's going to give me 1/3, 3 times 1/3, that gives me a 1. So I have 4 minus 4 plus x. I'm going to erase this and put that step in there. 4 minus 4 minus x, because these two equal a 1. So that gives me a -1 out here, and that's where I've got 4 minus 4 plus x. So that equals x. Whoops, sorry. So I'm good with f of g. What about g of f? I have 1/3 times 4 minus 4 minus 3x. So I work from the inside out. I'm going to have 1/3 4 minus 4 plus 3x. And that's going to leave me with 1/3 times 3x, which leaves me with x. Okay? So my answer is yes. Now, in these 3 examples, my answer ended up being yes every time, but it's not going to be yes every time, obviously. Questions? on that one? Okay. All right. I'm going to leave this open. I'm going to stop the recording, but I'm going to leave this open. If you end up with any questions, I'm still here. Otherwise, I don't have anything